All right, so today we are just doing a big lesson on factoring. By the end of the hour, hopefully you can factor all kinds of different things. This one was really simple. It just had an x in both of them. So I factored the x out, and here is the answer. I want you to try another one just like that. See if you can handle this one. 8x squared minus 4x. It's just a little more complicated because there's more than just an x in common. I hope you noticed there was a 4 in both of them. If you set a 2, you're close, but you got to take out as much as you can, and there's a 4 in both of them. And then there's also something else in both of them, an x. So if I take a 4x out of this, it's really dividing by 4x. And then the 8 and the 4 cancel, I get a 2, and then the x squared over the x gives me just an x. And then this is divided by 4x, and it gives me a 1, and there's a minus, so there we go. Raise your hand if you had that one right. Okay, good. Now that's the easiest kind of factoring. Try that one. It's very similar. We're hopefully going to get an answer next week on whether or not our seniors get iPads or not. If they do, I will have lots of cool things I'd like to show you with the iPad. In the meantime, those of you that are using it, cool. You're early adopters, that's fine. If you're not used to it yet and you'd rather just take it on paper, notes on paper, it's fine for now. The only way I'm going to go hardcore with that is if the seniors get them and we can all do it, then I'm going to do some hardcore iPad stuff. All right, I hope you took out the 2, and then you'd have x squared minus 4. Raise your hand if you had that one right. Okay, who was smarter than that? Ooh, one person. Nice. Ooh, yes? Yep. So, well, look out as in you feel like you're done with it and you think you got the right answer and yet you're wrong because it can factor again. This x squared minus 4 can factor again into x plus 2 and x minus 2. Do you get what I just did there? I took this part right here and factored it again. I know you did those last year. It's called difference of squares. If this is a perfect square and this is a perfect square, some teachers called it a lookout, as in, like, yep. All right. Now let's try one more like that. 6x to the 4th minus, let me think, 24. There we go. You're in pre-calc. You can't just do like simple algebra stuff because we're moving beyond that now. So it wouldn't be as simple as just factor out the 6 and you're done. It's the good start. The rest of the story is this can split again into what? X squared minus 2 and x squared plus 2. And some of you might think, well, can I do it again right here? No, because this one is not a perfect square. It has to be a perfect square like 4 or 16 or 25, things that have a nice square root. I can't do it with 2. All right, so this is done. That is the final answer. How many of you got to that? Okay, good. Moving on. Different kind of factoring. Actually, same kind of factoring. Sorry, one more time with the difference of squares. Seriously, it's going to come up over and over and over in this course, except it's going to be like sine squared minus 4. They're going to take this and make it a little more complicated, so we need to get this first. Okay, got 2 sets of parentheses, right? Unless you could find something that comes out of both of them, but 7 goes into this and it doesn't go into that, so there's nothing in both of them, so I can't pull anything to the front. So I make my 2 parentheses, and then I go, instead of 16x squared, I can break that into 4x and 4x, because that's its square root. And instead of 49, I use 7 and 7. And then what's the pattern, rest of the pattern? A plus and a minus. There we go. Raise your hand if you had that one right. That's half of you. All right. Put that right there. Thank you, sir. All right. Moving on. That's another one. It's just backwards. This is important. Five and 5, plus and minus, 3x and 3x. Hit that? All there is to it. Just take the square root of this, put it here and here. Take the square root of this one, put it here and here. One more that they are going to throw in just to screw you up. Don't fall victim to it. You'll go, oh, I see the pattern again, and make your little deal. No, you cannot factor that kind. It's called a difference of squares for a reason. That one is a plus. You can't factor that. You might say, why? Why don't want to work? X plus 5, x minus 5. Because when you do the first, you get x squared. That's good. Last, you get negative 25. Wait a minute. You get negative 25. See? Not positive. And then you might say, well, can't I just change to a plus? Well, then you're going to have outside and inside are going to make 10x. See, there's no 10x there. So this is not factorable. What's the word you use if it's not factorable? Prime is correct. They're called prime. If you cannot factor them, they're called prime. Just like numbers that can't factor, like 7. You can't break that up into something times something, except with a 1, which is kind of cheating. So that 7's prime. 13's prime. Things that can't factor are prime, including these. If they don't factor, they're prime. Okay. Here's plain old-fashioned factoring. Try factoring that. You should be good at that. This should be an easy one for you. X and X, and then, well, I got to make a 10. Not that complicated. Something times something has to make 10. So it's either 5 and 2 or 10 and 1. It's the only choices. Usually teachers don't use the 10 and 1, just the way it is. So they will probably be using the 5 and the 2. So then a 5 and a 2. And then one of them has to be negative, but not both. Because if they were both negative, you wouldn't get a negative 10 answer. See? One of them has to be negative. So then you pick which one do I make negative. You can try either one and it won't matter. Just guess and check. I mean, there is a smart way to do this, but if you just guess and check, you check by going like this, outside and inside, and I get a total of negative 5 and positive 2 makes negative 3. That's the opposite of what I wanted. So then switch the signs. Switch the signs like this, plus and minus. Okay, so if you ever get the exact opposite of what you wanted, just switch the signs. If your answer is like way off, then you got to switch the numbers. All right, let's try another one like that. Just plain old-fashioned factoring. If there was a top 5 things to know coming into this class, factoring is definitely one of the top 5. Like, if you can't factor, you're in some trouble. So our hardest problems have the factoring in them, and then by being able to factor them, things cancel and it makes them easy problems. But if you can't factor, you're left with these brutally hard problems. So, all right, X and X, and then 6 could be broken into 6 and 1, but I said usually you don't do that, and this is not the case of that. So then I have a 2 times 3 makes 6, and then if I put in pluses, will it work? I check. First, x squared. Outside, inside makes a total of 5x. Lasts makes 6. It works. Raise your hand if you knew that. Awesome. Moving on. 2x squared. Ooh, this one's different. Now this one you can't just do, oh, it multiplies to this and adds to that. A lot of people have that little crutch that it has to multiply to this and it has to add to that. It will not. It will have to, x and x. The firsts have to make 2x squared. How can I make that work? Put a 2 in there. Now it'll make 2x squared, see? The lasts have to make 4. So how do I make a 4? Probably a 2 and a 2. Or it could be a 4 and a 1. Now, it's not always that we use the 2 and the 2. Maybe it's the 4 and the 1 here. I think it's the 4 and the 1 here. Now, since there are only pluses in the problem, very easy, pluses. And last thing is either 2, 2, and I try 2 and 2, and outside and inside I get 6x, not 9x. So that didn't work. Try something else. 4 and a 1. 4 and a 1. Outside 2, inside 4, I get 6x again. Dang, didn't work. Switch them around. 1 and a 4. Outside 8x, inside 1x makes a total of 9x. There it is. Who had it before I had it? Okay, good. Down to about half of you. This is harder kind, no doubt. I have another one like that. Try this one. Two sets of parentheses. Then I'm going to go 4x and x. Now I could have gone 2x and 2x. I don't know until I try it. It's guess and check. It really is. There's a complicated method that'll always work, but it seriously takes you like 3 days to learn. And you're not going to have that many of these things, and then you'd forget that complicated method. So guess and check, it's the way to go. Just try stuff. And the way you try it is you're foiling it out. Firsts, at least I know they work. My lasts, well, it has to be a 2 and a 1. That much I know because it has to multiply to a 2. One of them has to be negative to make it negative 2. So it's a 2 and a 1, and now it's just down to playing with the 2 and the 1 and the negative to figure out where it goes. And you just got to try stuff. And this is 4, and that makes 2, total of 6x. Missed. Didn't work. What if I go with a 2 here and a 1 here, and then I get 8 and a 1? That makes 7, kind of, if I can get a subtract in there. And can I? Yeah, because 1 has to be negative. So then I go, okay, I need it to be positive result, so I want the bigger number to be positive, so let's make that guy positive, and this one negative, and I try it and see if it works. Outside, inside, total of 7, and the lasts make negative 2. Yeah, excellent. All right. This one, I'll warn you, has a trick to it that a lot of people don't see right off the bat. Does anybody see it? What? Say it. Take the 2 out. You are correct. If you try to fight through this with 2 parentheses, you'll take forever. Instead, if you notice that all of them have a 2 in it, get the 2 out of there. 2 comes out first. So anytime, I'm warning you, when you get to your test, anytime you have one that is just brutal, look and see if there isn't something you can pull out of everything. And isn't that the exact same one we just had? See what I mean? All of a sudden now it's just the same problem as before. And we already know that answer. We just factored that 2 seconds ago. 4x and x had to be a 2 and a 1. One of them's negative, one's positive. That one must be positive, that one must be negative. There we go. That's the most complicated kind you'll have. Yes?
Can you put, instead of having 4x, choose 2x instead?
You can, but here's what the problem would be. Let's say that I had a 2x and a 2x, and this was a 2x like this, okay? And this was a 2x right here. You're going to not notice that something like this has a 2 still in both terms that needs to get factored out. So you could do it the way you just said, and it would work. It would factor, but you wouldn't notice that one of your terms isn't factored all the way, and that's one of those lookout ones you were telling me about. How you can't notice, oh, wait a minute, I'm going to get it wrong, because you don't even notice that one of your factors could be factored again. 2 can come out of both. All right, so don't do it that way. Here's another one, and this is comically large, ridiculous numbers, so it's trying to give you a hint on what to do. All right, so here's what I would have done. 10 comes out, and you got x squared plus 4x minus 5. And then You can factor again. X and X, and then 5 can factor into 1 and 5. One of them's got to be negative. So I think about it. If I go like this, I'll get a big negative number. I don't want that. So make that positive and that negative, and I double check it at the end. X squared is these two. Outside is 5x, inside is 1x, or minus 1 makes 4x. And the last make negative 5. Yay, got it right. And how many of you had it right? All right, you're following me really well. Good job. This one's another, like, seems ridiculously hard. So what are you going to do? Take something out, in this case, an x. Very good. And then it factors easy. Six could really be 2 and 3. Double check it. First, x squared. Outside and inside makes a total of 5x. Last, 6. That's it. Some people ask, do you still need this x? Yeah, because the point of this is that we have to multiply it all out to get this back again. If we don't have this x here, some people drop it and it's wrong, then all we get is this. We don't get the original thing back again. So you need the x in front, yes. All right. I think I've gone kind of beaten this to death. This one looks really hard, so the first thing you should do is take an x out or take a number out. Numbers won't work, so take an x out. Yep. This is the last kind I want to talk about. It is definitely trickier than the average factoring problem, but some of you are going to go, I see it right away. Give it a shot, and I'll see who are the I see it people. Factor it. All I'm asking you to do is factor it. You can't solve it because it doesn't say equals anything. All you can do is factor it. You could simplify it a little bit, but you could factor. Who notices something they can do? Raise your hand if you think you got some idea what to do. All right, awesome. Fontaine, you want to tell me what to do? You got it. Just like both terms have an x in it, if I go like this, 8x plus, let's make it, s's are bad letters, just because they look like 5s. Ax, do you get how they both have an x in it, and I can take the x out to the front, and I'd have 8 plus a left? Because they both had an x in them. These both have an x minus 5 in them. So I can pull it out to the front. That x minus 5 goes out here. And once I pull out the x minus 5s, what am I left with? 3 plus 8. 3 plus 8 is the same as 11. Final answer? 11. Don't interrupt. Or I can put the 11 up in front. And there's my final answer. 11 times x minus 5. Couldn't you have just noticed that it was 3x minus 5s plus 8x minus 5s? Make a total of 8 and 3 is 11x minus 5s? Yeah, that works. All right, now you had something? Don't you have to square it? Okay, how about this? Tell me, I know you're thinking, because I had 2 of them, that I have to square it. But it's not true. Because look, I had 2 of them here, and I didn't square it when I took the x out. Right? The reason there's going to be 2 of them again is because of distributive property. See how it's going to happen twice? That's why you don't need to square it, because it's going to happen twice. It's going to get distributed to both parts. And if you just think about it, if I multiply this all out, it'll be 3x minus 15 plus 8x, and the the 8 minus 5, or 8 times the negative 5 would be negative 40. You put it all together as 11x, and then this is negative 15, and negative 40 makes negative 55. Isn't that the exact same thing as that? It is. You don't need to square this. Trust me. Don't square the thing you pull out in the front. All right. Another one like that. See who caught that. That is the hardest kind of factoring that we do. There's actually when you took HA last year, you learned this thing called synthetic division, which allowed you to factor even harder things. We won't get that far. That cell phone goes on my desk. And here's my deal. You get caught texting in my class, or checking the time even, because that's what you're going to say. You're not going to say you're texting. Then you have a choice. The phone goes on my desk, period, till the end of the hour. You can either bring in treats for everybody, or I can send the cell phone down to the office. Your choice. I'll let you think about that till the end of the hour. I know what you guys want. And it doesn't have to be tomorrow, because I know you're probably going to get mom to get the treats for you, and you're probably not going to tell her it's because you were using a cell phone in class, but you're going to say, I want to bring treats to my class. Anyway, so you got to get it to us within a week. Okay? It's up to your choice. All right. And I will, though, if you're a chronic texter, but you also are just fine with bringing in treats, that's not going to be okay. If you continue to do it, I will just start sending them to the office, and you don't have the option to do the treat thing to absolve your sin. All right, moving on. Number, I guess, whatever problem number this is, this guy comes out to the front. I hope you noticed that. And then the harder part is, when that comes out to the front, what's left? 5 plus A. I know that kind of feels weird. It's always hard for kids to get this kind, but raise your hand if you had that one. All right. Why does it work? Because if I multiply it out, it will work. If I multiply this out with FOIL, first, outside, inside, last, it'll give me the exact same thing as if I multiplied that all the way out. And then save 5 minutes. I'm not going to actually do it, but trust me that it will work if I actually multiply them both out. Yes?
Does it matter if 5 plus 8 is
Nope. If you want to write 5 plus A here and x minus 2 there, totally fine. Doesn't matter. Because if you FOIL it, same answer. That's the commutative property of math, is that, or multiplication, is that multiplying, you can do it either order you want. You want to say 3 times 5, you want to say 5 times 3, same thing. Okay. The last part is 4-part factoring, which I have realized we're not going to test you on, so I'm not going to remind you about it. So, neato picture, but unnecessary. Okay, so here is your worksheet for today. It's all factoring all the time. And that's the end of my video for today. Save.